Alright, for this last section, we're still looking at our limits, infinite limits, limits at infinity. But this time we're going to have square roots in our rational functions. So when you have square roots in your rational functions, it's going to have the shapes like this. So they're actually going to have two horizontal asymptotes. So just to look at this using the graph, if we ask the limit as x approaches negative infinity, we're talking about this left end behavior. So that's approaching that horizontal asymptote of -2. And then the limit as x approaches infinity, so the right end behavior, that is approaching that positive 2 horizontal asymptotes. So when you have the square roots here, we have two different horizontal asymptotes. Okay, so we're going to do this the same way with the algebraic analysis. The only problem is because we have the square roots, we have to do something just a little bit different. So whenever we, these you're going to have to do the long way, because if you try to use the shortcut, you may run into a little trick on there. So you're going to have to do these using that algebraic analysis. So normally you're going to divide by the highest power in the denominator, which we're still going to do that, but that square root is included. So because it says the square root of x squared, that is just x that we're going to divide every term by. The other thing that you have to be careful for here, you're looking at if this is positive or negative infinity. If this is positive infinity, then you're going to divide it by positive x. If this would have been negative infinity, you have to divide by negative x, okay? Because no matter if this is positive or negative, if you put this in here, it would still be a true statement. So in the numerator, we're going to divide each term by positive x. Now in the denominator, because it's under the square root, you're just going to be dividing by that x squared. Because x squared divided by, okay, so this is a little confusing for the setup. So when you're doing the numerator part, you're dividing by the square root of x squared, because that's really what this term is. We made it a positive x because we're doing the limit as x approaches infinity. But in the denominator, you're still going to be dividing by just x squared, because that's the same thing as dividing by x because it's underneath the square root. So when you have the square root, what you're dividing by is going to look a little different here. So we're going to simplify that out. So we'll have 2 minus 2 over x over the square root of 1 plus 1 over x squared. And then we're doing the limit as x approaches infinity. So from here, you're doing it the exact same way. So the limit as x approaches infinity of 2, which is just a constant, is going to be 2. Minus, we have the small over big, so that's going to be 0. Over, you do have to keep the square root. Constant, which is going to be 1. Plus small over big, which is going to give us 0. So we're going to have 2 over the square root of 1, which is going to give us 2. Okay, and so that does tell us that we have that horizontal asymptote at y equals 2. And this is the same problem that we had up here, and we confirmed that with our graph that that was true. So now we're doing the same problem, but we're going to do the limit as x approaches negative infinity. So you're still going to be divided by the highest degree in the denominator. But because it has this square root, the square root of x squared is just x. But because we're working with negative infinity this time, you're going to be divided by negative x. So in the numerator, we're going to be divided by negative x. Now in the denominator, because it's under the square root, you're still just dividing by that x squared. Okay, so when you're dividing by these two things, you're really dividing by the same thing because it is square roots. Just know that. So if we simplify, we're going to have negative 2 plus 2 over x over the square root of 1 plus 1 over x squared. So now we're doing the limit as x approaches negative infinity. So the constant will stay negative 2. Small over big is going to give us 0. Keep our square root. Constant 1 stays. Small over big gives you 0. So we're going to have negative 2. which is what we said the answer should have been up here from our graph. So this means we have a horizontal asymptote at y equals -2. Remember, with your square roots, you're going to have two different horizontal asymptotes like we had in the graph. And the way that you figure that out is because remember when you had to do this square root of x squared, because we were working with negative infinity, that's where that negative ended up coming from. So if you forget that negative, it's going to mess it up. Okay. Alright, so just a few more examples of these. So here we have our square roots, so we just have to be careful. So we're dividing by the highest power in the denominator, so that's going to be the square root of x squared, which is x, but we're doing the limit as x approaches negative infinity, so we have to include the negative. So in our numerator, we're going to divide by -x. In the denominator, we're just dividing by the x squared. Okay, so if we simplify, we're going to have -3 plus 2 over x divided by the square root of 2 plus 1 over x squared. Now we're ready to find the limit as x approaches negative infinity. So when we plug in, we have a constant which stays -3, small over big which is 0, over the square root, constant 2 stays, small over big is a 0. So we're going to end up with -3 over the square root of 2. So this tells us that we have a horizontal asymptote at y equals -3 over the square root of 2. Just remember, if I would have asked you the same problem, but the limit as x approaches positive infinity, you would have ended up with the same answer, but it would have been +3 over square root of 2. So hopefully you can see that you can actually do this the shortcut way too, if it's not enough for your response question. So you have your same degree. These are technically the same degree here because it's under the square root. And because it has the same degree here, the 3 is the coefficient here, and the square root of 2 is the coefficient here. But we had to use the negative because it was the negative infinity. So you can kind of see the shortcuts and kind of double check your answers down here. So for this one, let's look at it and then we'll look at why I don't think, oh, I can just use the shortcut, because look what's going to happen. So we're going to be doing square root of x squared equals x. It's positive infinity, so we're going to be dividing by positive x. And then in the denominator, you're dividing by the x squared. So if we simplify, we're going to have x plus 2 over the square root of 3 plus 2 over x squared. Okay, so this is one of the ones where we have this variable here, so the x, if you remember from the previous problem, we just plug in that infinity there. So infinity plus 2 over the square root of 3 plus, we have small over big, so that's 0. Well, a really big number plus 2 is still going to be a really big number, infinity, divided by square root of 3. Well, even if you divide by square root of 3, it's still going to be a really big number. So we do end up with infinity for this, okay? So what that means is, this just means there's no horizontal asymptote. For the rational functions with the square root in them, they don't have slant asymptote, so this doesn't mean you have a slant though. So I wanted to look at like the shortcut way just to make sure this confirms what we said. So really we would have x squared for the degree over the degree in the denominator would really just be x. So remember, when you have big degree over small degree, that means you have no horizontal asymptote. So that makes sense there. Okay, so that's why we ended up with that. But just note that whenever you have square roots here, when you end up with infinity or negative infinity of your answer, it just tells you no horizontal asymptote. It doesn't mean that you have a slant asymptote.